Hi friends, so today we are going to discuss about stroboscope. So stroboscope is a device finding the speed of rotating objects in terms of RPM. So stroboscopes are used to measure angular speeds between 600 to 20,000 revolution per minute. It is also called as contactless stroboscope. Its advantage is that it does not need to make contact with the rotating shaft. So without any contact, we can measure the speed of the rotating shaft. What is stroboscopic effect? Means here high-speed vehicles are moving in forward direction. So our light intensity, our observing high intensity frequency is not matching with the speed of the vehicle. So our eyes are seeing is not matched with the frequency of the vehicle. So high speed vehicles are moving in one direction, in forward direction. We observe that it's moving in anti-clock direction. The wheel of the vehicle is moving in opposite direction. So because our eye frequency is not, high intensity frequency is not matched with the vehicle frequency, that effect we can call it as stroboscopic effect. Okay, so with this principle of operation we are using in stroboscopic transducers. Okay, the main principle of stroboscopic, how it works is, from the stroboscope light intensity is coming, the frequency of light intensity will measure the speed of the rotating shaft or speed of the object. Okay, so when the light intensity is coming from the stroboscope, we can measure the speed of the shaft or rotating object. So here what are the main important components in stroboscope means, one is flashing bulb to change the light intensity frequency. One we are using flashing bulb. Second one is speed of the input shaft, and speed of the whose speed to be measured is one of the important point. The second one is rotating shaft. Okay, so these are the three important points. So how we are constructing the stroboscope transducer, what is the working principle, we will see now. So here we are taking one input shaft whose velocity to be measured. We can take this as a motor shaft or engine shaft or any whatever rotating object we will see as a, we will take it as an input shaft. This speed is to be measured, we can call it as speed source or input shaft. So another important rotating object, that is a disc shaft or rotating object. Let us assume the disc shaft is moving or rotating in the input shaft is rotating, the disc shaft is also rotating in the same direction or anti-clockwise direction. The disc is marked at one marker. So at the same frequency, when the measured input torque is moving, the disc of the rotating torque is also moving with the same speed and same direction. And the next part is stroboscope. Here we are taking a flashing bulb, on-off flashing bulb. So here from this light energy is coming. So here this instrument, by changing the light intensity, the frequency of adjusting knob is there. So we can adjust the light frequency by adjusting the frequency knob. The scale is showing in the frequency in the top of the stroboscope. We can directly measure the frequency in a calibrated scale. So it gives the value of frequency. So these are the different parts in stroboscope. Now see what is the working operation. So when the input shaft is attached to the disc shaft, the input shaft is rotating in anti-clock direction. Disc shaft is also rotates. The flashing bulb is coming from the stroboscope connected to the rotating shaft. So by adjusting the frequency of the stroboscope, the light intensity is increasing by adjusting the knob, increasing or decreasing. At some frequency point, one mark, the disc should be appear stationary. The mark should be appeared stationary. It should not be moved. The mark is appeared at one place. because of stroboscopic effect, that frequency of light is equal to speed frequency of the moving object or rotating object. So the mark will appear stationary. So the stroboscope, you are connecting parallelly to the moving shaft. So with this arrangement, the light frequency at one place, the disc shaft marked as a stationary. So the frequency of light is equal to the speed of the rotating shaft. Directly you can calibrate it in a stroboscope frequency scale. Okay, so these are the working principle and operation of stroboscopic transducer. Okay, so this is also contactless, and the advantage is the accuracy is very good, and it is a contactless, so no moving parts. The accuracy of this instrument is very high, and no contactless of rotating object, and the stroboscope we can measure it from anywhere. Okay, this is very portable. So what is the limitation here is, so always we have to adjust the light frequency flashing bulb. You have to adjust the bulb, calibrating the bulb, replacing the bulb every time. That is the only limitation. Okay, so stroboscope is more portable, so anywhere we are using, but we have to measure the angular frequency in between 600 to 20,000 revolution per minute. So this is one of the important device we have to use for rotating objects like missions, rotating objects, engines, mission speeds, and shafts, motors. So like that we are using in many more applications, in industrial applications. Thank you. Thank you.